Alright, now that we have clear understanding of how SPSC queues work, let's start building it and make our hands dirty. First of all, I've imported all the necessary standard C++ headers and then defined the namespace. Just to keep the data type generic, I've used template type name T, so as we don't want to stick around with a specific data type, and then defined SPSC queue class where we'll define the private member variables. So first of all, as we know, the buffer ring is logically a vector, so we define a vector and name it as buffer, and then capacity, head, tail, and then we'll define the SPSC queue with the parameter capacity, and then we'll use the member initializer list. In C++, class members are constructed before the constructor body runs, and the initializer list lets us construct them directly with the correct values. This avoids unnecessary default construction and reassignment. Now that we also looked on how the enqueue and dequeue functions work, let's start defining it. So the enqueue function will have an item as the parameter, and then we'll define the next tail, which is basically the tail plus 1 modulo capacity, and we'll make sure that the head isn't equal to the next tail, in which case we imply that the queue is full and will return false. If that's not the case, we'll insert the item at the tail index and then update the tail to the next tail and return true. Now let's define the dequeue function. In the dequeue function, first of all, we'll make sure that the head is not equal to tail. If that's the case, then basically the queue is empty, there is nothing to read, and then we'll return the null optional value. If there is data, then we'll dequeue it and read it from the head index, and then update the head, which is basically head plus 1 modulo capacity, and return the item. Also, we'll have the empty function, which basically returns if head equals to tail. Alright, now let's start defining the main function, where basically first of all we have defined the queue size, which is 10, number of iterations, which is 5 million, and then we constructed a SPSC queue and passed on the queue size. We also define a done flag to imply that the producer thread has done inserting all the values. Alright, now we have to construct two different threads, producer and the consumer. Producer will insert at the tail index, while consumer will read from the head index. So we'll basically insert up to 5 million values, and we will use the enqueue function to insert the values, and once the producer is done inserting, it will flag the done flag as true. Similarly, we will be defining the consumer thread, where basically it will check if the done flag is true. Then in that case we don't have anything to read, and if that's not the case, we'll keep on reading, and also we'll make sure that the queue isn't empty. So if either of the case is true, then we'll keep on reading, and it will dequeue the values, and we define the consumed vector, where basically we'll insert all the dequeued values, and then we start both of the threads using the join operator. After the producer and consumer threads are done reading and writing, we'll check the results. So basically I'll check all the duplicate values and the lost values. It will be more obvious once we actually execute the code. So for that, let's start executing the code. And now it's compiled, and I'll run. So as you can see, the consumed values are 5 million, there is no lost value, there is no duplicate value. We'll execute it again, and you can see there is one lost value and one duplicate value, and this is the lost value, this is the duplicate value. We keep on running for a few more iterations. So you can see the number of lost values and duplicate values keeps on changing. Why is that happening? Come on, let's discuss.